Welcome to Forensic Science. This time around is on pH. I'm Miss Yong. Now for pH, I will need to introduce to you a few things. First is acids. Acids has a pH of less than 7. Acids are substances that release hydrogen ions in the presence of water. And hydrogen ions are positive ions. It's actually the hydrogen atom lose one electron to form hydrogen ion. So the common examples of acids are citric acid, for example. It can be found in lemon, orange, the fruits that you eat. There's also the malic acid that can be found in the apples. Now in a chemistry lab, there are 3 common acids. One is nitric acid, the acid that you use when you test for anions in qualitative analysis. The other one is sulfuric acid and hydrochloric acid. All these acids have a pH value of less than 7 and they turn blue litmus paper red. Now the stronger the acid, the higher the concentration of hydrogen ions in the solution and hence a lower pH value. That means there's more hydrogen ions present in the solution. Next, alkalis. Alkalis have pH greater than 7. Alkalis are substances that release hydroxide ions in the presence of water. Now, hydroxide ion is a negative ion. So, some examples of alkali are your chlorine bleach solution that can be found at home. In a chemistry lab, you will see sodium hydroxide. Again, this is the one that is used to test for cation in qualitative analysis. There's also lime water, which is used to test for carbon dioxide gas in qualitative analysis. There's also aqueous ammonia, which is to test for your cations in qualitative analysis. Now, all these alkalis have a pH value of greater than 7 and they turn red litmus paper blue. This is different from your acid. Now, the stronger the alkalis, the higher the concentration of hydroxide ions in the solution and they have a higher pH value. So, which means your alkalis have more hydroxide ions in the solution. Next, for neutral solution, they have a pH of 7. So, when the neutral solution is tested with red and blue litmus paper, no color change is observed. An example of neutral solution is your pure water. All neutral solutions will have the same concentration of hydrogen and hydroxide ion. It's the same amount, hydrogen and hydroxide ion. Now, so how do we use red litmus paper and blue litmus paper to test for the acidity, alkalinity of the solution? If the solution is acid, its acidity will cause the blue litmus paper to turn red, but the red litmus paper will remain as red. If it's an alkaline, it will cause the red litmus paper to turn blue and the blue litmus paper to remain as blue. Okay, so this is a picture of the litmus test. Can you identify which beaker consists of acid and which beaker consists of alkaline? Pause the video and observe it. Okay, now back. Are you able to tell me which one is an acid? Now this is the blue litmus paper. Upon touching the solution, after they dip in the solution, it turns red. So which means this is an acid. And for B, this is the red litmus paper. Upon touching the solution, it turns blue. So this is an alkali. Okay. If we are talking about neutral solution, the red litmus paper will remain red and the blue litmus paper will remain blue. Now, you can also determine the pH value using the universal indicator. A universal indicator is an indicator that it contains of a mixture of substances that are able to give different colors corresponding to different values. So these are how the colors look like. You notice for the acidic solution, the pH 0 all the way to less than 7. It's red, orange, yellow, light green to green. And if it's an alkaline, it will be from green to blue to violet. Is an alkaline. So the colors actually gives us the pH values as well. Now, so yes, pH 0 to 2 is red, 3 to 4 is orange, 4 to 6 is yellow, 7 is pale green, this is neutral, and 8 to 11, green to blue, 12 to 14 is violet. Okay. Now, other than using universal indicator to observe the color, we can also use a pH meter to measure. So a pH meter, okay, will be able to tell us the pH value. Of course, from the pH value, we can calculate the concentration of hydrogen ions and hydroxide ions, but we are not going to that calculation, don't worry. So if it's a strong acid, usually pH 0 to 2, it will have a very high concentration of hydrogen ions and very low concentration of hydroxide ion. As for weak acid, the pH value is still less than 7. It will have high concentration ions, but this concentration ions are actually less than the strong acid. And for the hydroxide, it will have more hydroxide than the strong acid, but still considered low. There will be more hydrogen ions than your hydroxide ions for acid. Then if it's neutral solution, pH value is 7, and it will have the equal concentration of hydrogen ions and hydroxide ion. For weak alkaline, pH value is greater than 7. They will have a high concentration of hydroxide ion, definitely more than the neutral solution. They will have a low concentration of hydrogen ions, definitely less than the neutral solution. For strong alkaline, pH 13 to 14, it has a very high concentration of hydroxide. That means it has the maximum concentration of hydroxide ion compared to the rest of the solution. It has very low concentration of hydrogen ions compared to the rest of the solution. And yes, it has more hydroxide ion than hydrogen ion in alkali. So looking at the pH scale 1 to 14, sulfuric acid, nitric acid, hydrochloric acid are considered strong acid. The pH is about 1 to 2. So when you go to the lab and you see this acid, please be more careful. If you have it on your hand, make sure you wash your hand thoroughly with water. Ethanoic acid, your vinegar that can be found at home, is a weak acid, pH 3, pH 4 or 5. There's also water, neutral solution, pH 7. Aqueous ammonia is a weak alkali, about pH 9 to 12 or 11. Yeah. Sodium hydroxide is a strong alkali, pH 13 and 14. So so you'll be using all these chemicals, reagents in the chemistry lab. So please be careful. If you have it on your hand, please wash it, and please do not touch your eyes or your face. Okay, once you touch it, please go and wash it. Okay, I've come to an end of your pH test. I'll be showing you a video on how you can test for pH, how can you determine a value, or how can you use a litmus paper to test for the acidity of the solution. Watch the video and happy learning.